A rigid body does not undergo any kind of deformation, students. So based on to internal restoring force, students, based on internal restoring force, substances are classified as elastic, plastic, and rigid. Based on the internal restoring force, students, substances are classified as elastic, plastic, and rigid. Okay. We are trying to go for elasticity, students. When we speaking about rotational dynamics, students, वहां पे हम लोग ने rigid body लिया था. We went for rigid body, students, a body which does not undergo deformation due to external forces. यहाँ पे क्या हो रहा है? In case of elastic body, students, bodies will undergo deformation due to applied force, but at the same time, when the forces are removed, the body will retain its original shape and size. Such bodies are called to be elastic body. Since when I speak about elastic body, if I consider, for example, you go for a rubber ball. Okay. Now to this rubber ball, students, you apply force. What happens to the rubber ball? The rubber ball will undergo deformation. The ball will simply undergo some deformation, students. यानी look over here, यहाँ का जो particle है, वो यहाँ पे आके displace हो गया. Even the particle which was over here, it's undergoing a displacement over here. Due to what? Due to the deforming forces. But since the internal restoring force is slightly less as compared to deforming force, therefore the body has undergone a change in shape. Lekin such a change in shape, students, is temporary. Such a change is temporary. If I try to remove this forces, what's going to happen? Again, the ball will retain its original shape back. Such an object is called an elastic object. So students, an elastic object is a body which undergoes deformation due to external forces, but when forces are removed, the body can retain its original shape and size we consider. Such bodies are called to be elastic. A second way of representing it is a body which resists. See, when you go for the exact definition, students, one can say elasticity is defined as what? Elasticity is actually, we consider as what? Tendency of a body to resist in its shape and or size. A body which undergoes kind of a resistance. Please students, do keep in mind, elasticity का मतलब क्या है? A body which has a tendency to resist what? Change in its shape and or size. Such bodies are called to be elastic body. Welcome, Janani. Why so late? Janani, why so late?
Sir, I completely, fell asleep and I just woke up right now. I'm sorry.
Okay, very good. You're having a good time. Dala time. Dala enjoying the life. Students, how was the test? Was the test conducted on Sunday?
No, sir, it was cancelled.
It was cancelled.
Yes.
And it was only on to kinematics 1, or what exactly it was?
Kinematics excluding relative motion.
Okay, fine. So students, what exactly elasticity, students? Elasticity is a property we consider by virtue of which a body resists any change in its shape and or size. Such bodies are called to be elastic. Any elasticity का मतलब ये भी है, students, the body should resist. It should not allow any change in its change or shape or size. Or you can say deformation should not take place in that. Such bodies are called to be elastic body, we consider. So, and that is based on to what? Based on the internal restoring force. Abhi internal restoring force kaun de raha hai? Internal restoring force kaun de raha hai? It's the force of attraction between the atoms and molecules. That's what it calls the internal restoring force. So when somebody asks you what is elasticity, then what is your answer? Elasticity we consider is a property by virtue of which a body resists any change in its shape or size. A body which undergoes deformation, permanent deformation, such bodies are called to be plastic. A body which does not undergo any deformation, such bodies are called to be rigid body. To understand elasticity, we go for the body resists in its change in shape and or size. That is what a student should keep in mind. Now let us go for certain mathematical terms or the definitions related to elasticity, students. The first term we have it is stress. Now students, what exactly stress is considered to be? Stress, students, is defined as what? It's the restoring force acting normally per unit area. Stress is defined as, students, restoring force acting perpendicularly per unit area of a given body. That is what we call as stress. Force acting perpendicular. But which force we are trying to go for? Restoring force. Now, this particular stress, if I consider this stress, can be considered of three types. The stress can be considered as three types. You can consider as longitudinal stress, or you can consider volume stress, or you can consider shear stress. Three kind of stress. Longitudinal, also called as tensile. The other one is tensile stress. Second we consider is volume stress. Third one is shear stress. Abhi ye stress hai kya, students? Stress ka see what exactly I've given you? It's restoring force per unit area. What exactly? Its unit will be what? Its unit will be Newton meters square inverse. Can I call it to be as pressure? No. Dimensions, students, dimensions of pressure and stress are same. But pressure is perpendicular force per unit area. Stress is restoring force per unit area. To understand this concept of stress, let us take a simple example for longitudinal. Now, please pay attention. Let us understand this part. Longitudinal stress. That will make you understand the concept of stress more better. Now, for example, students, I'm taking a wire, okay, a wire which is elastic in nature, we consider. Now, this wire, the wire what you consider is actually thin. The thickness is very small in that case. But when one draws it on the board, the wire will look like a cylinder, students. This is what the wire is. Let us say this wire is of length L, students. Okay. Now, this is what is the base area of the wire. I can consider this is the area of the wire, because every cylinder, a wire is a cylinder, students. And if you see the base will be what? Circle. That means what exactly the area of this part we consider is pi r square. Now, students, I want to elongate this wire. Students, I want to elongate this particular wire. So what I'm going to do? I'm trying to apply load to this. Jaise मैं load, if I start loading this particular wire, if I start putting load across it, what's going to happen? As I go on adding load to it, what is going to happen? This becomes my applied force. Look at my applied force. Where is my applied force acting? In the downward direction. What is my force applied? You'll say, sir, equal to the load. What is load over here? M into G. How can you measure this load? What is the unit to measure load? It can be either in kilogram force or it can be in gram force. Students, where exactly this force is acting? Students, this force is acting, the applied force is acting onto the atoms and molecules of this particular wire. Students, look at the atoms and molecules. Look at the atoms and molecules. This wire I've taken to be highly elastic in nature. Now, when I use the word highly elastic, what exactly it means? Resists. It resists any change in its shape and or size. Yani लोड अप्लाई कर रहा हूं, दैट लोड, दिस पर्टिकुलर लोड और दिस पर्टिकुलर फोर्स इज मेड टू एक्ट ऑन दिस पर्टिकुलर एटम, यानी ये फोर्स इस एटम को अपनी तरफ खींचना चाहता है। ये जो अप्लाइड फोर्स है वो इस एटम को इट्स ट्राइंग टू पुल इट टुवर्ड्स इटसेल्फ। बट व्हेन यू सी स्टूडेंट्स, look at this atom. Is this atom having another atom very closely and compactly placed? Yes. What is this atom is going to do? This atom is going to exert a force of attraction. What is that force we call? Interatomic force of attraction. The force of attraction between two atoms we consider interatomic force of attraction. ये जो atom है वो ऊपर वाला इसको attract कर रहा है, ये वाले को ऊपर वाला attract कर रहा है। Yani, if I'm trying to pull this atom 1 in the downward direction, 2, 3, 4, all of them are getting a force in the upward direction. What is this force is going to do? ये कौन सा force है students? ये है interatomic force of attraction of the atoms and molecules. This interatomic force is actually the restoring force. Students, when somebody asks you what exactly you mean by internal restoring force, so what is an internal restoring force? Internal restoring force, students, is nothing but simply interatomic force of attraction between atoms and molecules. अभी देखो, rigid body अगर तुम लेते हो students, rigid body लेते हो तो rigid body में how the atoms and molecules are very closely packed. Intermolecular space बहुत ही negligible है students यहाँ पे। तो students यहाँ पे internal restoring force क्या होगा? For a rigid body, students, internal restoring force is very large. If I take an ideal rigid body, the internal restoring force is infinite. That is why such bodies never undergo deformation. That is why rigid body never undergo deformation. अगर मैं plastic body लेता हूं तो वहां पे the plastic body के अंदर atoms and molecules are slightly away. अगर तुम उसको डिफॉर्म करोगे तो वो परमानेंट डिफॉर्मेशन हो जाएगा। टेक अ सिंपल एग्जांपल ऑफ अ टीटी बॉल स्टूडेंट्स, अ टेबल टेनिस बॉल। टेक अ टेबल टेनिस बॉल स्टूडेंट्स, और वो टेबल टेनिस बॉल को यू हिट इट हार्ड विद अ बैट और यू हिट इट हार्ड ऑन द वॉल, अ टीटी बॉल। डोंट यू थिंक सो द बॉल विल अंडरगो परमानेंट डिफॉर्मेशन? व्हाट्स द रीजन फॉर इट टू बी परमानेंट डिफॉर्म? क्या हुआ, क्या है, क्यों परमानेंट डिफॉर्मेशन हुआ? तो तुम्हें ये बोलना चाहिए सिर्फ वहां पे एटम्स एंड मॉलिक्यूल्स का क्लोज कॉम्पैक्ट नहीं है, यानी वहां पे इंटरनल रिस्टोरिंग फोर्स इज लेस। यहाँ पे इंटरनल रिस्टोरिंग फोर्स is less, is the least I can consider. Over here, in elastic body, we consider the internal restoring force is considered to be maximum, but not infinite. It has internal restoring force, but maximum, but not infinite. That is why such bodies, if I try to deform, they'll undergo deformation, लेकिन वापस अपने जगह पे आ जाते हैं. Yeah, they resist any change in its shape or size. Such bodies are called to be elastic body. So now see over here, how is stress defined as? Stress is defined as restoring force acting perpendicularly. Look at this force. Is this force acting perpendicularly? Yes, sir. Restoring force acting perpendicularly per unit area of a given surface. What is that called? That is called stress. जैसे जैसे ध्यान से सुनना, जैसे जैसे तुम लोड बढ़ाते जाओगे, जैसे जैसे तुम लोड बढ़ाते जाओगे, वैसे वैसे तुम्हारा अंदर का रिस्टोरिंग फोर्स भी बढ़ता रहेगा स्टूडेंट्स। Equal in magnitude, opposite in direction. That means, students, your applied force and restoring force are both equal in magnitude. Are both equal in magnitude. This is the applied force. But are they in same direction or they are in opposite direction? They are both in opposite direction. That is why some teachers also say stress is also defined as force applied normally per unit area. But actually, students, this is an incorrect way of representing it. This is incorrect. ये कभी use करते हैं only while solving problems. But conceptually, if you want to see what is stress, then stress is not applied force, but it's an internal restoring force. Now, if somebody asks you, can you give me the formula? What kind of stress is this we call? So we are speaking with respect to longitudinal. We are speaking about tensile. Other way is longitudinal tensile. Yes, negative of force applied we consider. Direction is opposite. That negative sign shows direction opposite. 50. Negative sign shows that the restoring force is in the direction opposite to the applied force. Now, suppose if somebody asks you, what's the formula for longitudinal tensile stress? What's the formula? Force applied per unit area. What is applied force? Sir, applied force to MGA. What is unit area? What is area of cross section of the wire? Pi. Can I say this is actually the formula for what? Longitudinal tensile stress. क्या ये clear हुआ students? Is this clear to all of you all? So first of all, what exactly students say? What exactly internal restoring force students? Internal restoring force is simply the force of attraction between atoms and molecules of a given substance. And that is actually the interatomic force. In solids, the interatomic force are very closely and compactly placed. Therefore, the restoring force is very large, we consider. Depending on the internal restoring force, in solids also, we can classify substances elastic, plastic, and rigid. If I take a perfectly rigid, perfectly plastic, perfectly elastic, then in perfectly rigid, internal restoring force is infinite. In perfectly plastic, internal restoring force is almost zero. Elastic, internal restoring force do exist. But at the same time, when I remove the forces, deforming forces, the body will come back to its original shape and size. But there is no body, the answer to our students, there is no body or there is no object in physics considered to be perfectly elastic, perfectly plastic, perfectly rigid. We can give examples. Students, for me, this particular pen can be considered rigid. अगर मैं ऐसा करूँगा तो it's not breaking. It's a rigid body. But can I break it? Yes, if I try to put it into a compressor. Two walls, making it to compress, so थोड़ी आएगा, crush भी हो जाएगा. I can make it into fine powder also in this case. So that depends what kind of forces you are applying on. The first concept we learned about is stress. If somebody asks, what is stress? How is stress defined as? Stress is defined as simply spins restoring force acting normally per unit area. What is a unit? Newton meter square inverse. What are the three different types of stress we consider? Longitudinal stress, volume stress, shear stress. Longitudinal stress speaks about what? Simply increase in length. Now, due to the applied force, what has happened? Due to applied force, what happens, students? The wire has undergone some elongation. See, this was the original length. Now this becomes the new length. So has wire undergone change in shape? Yes. This change in volume, the length has changed. From L, it has reached to L dash. Did the diameter change? No, the diameter has not changed. Please, diameter hasn't changed. Only the length has changed. Now, students, listen carefully. How can I say the body is elastic? कैसे बोल सकता हूँ? अगर सपोज मैं ये लोड अगर निकाल दूं अभी, ध्यान से सुनना, अगर मैं ये इस वायर को अनलोड करना शुरू कर दूं, see first load is removed, second load is removed, third load when I remove, as I go on unloading the wire, does your wire retain its original shape back? Yes. If it retains, such bodies are called to be elastic bodies. Or the body which resists any change in its shape and size are called elastic. Is this clear to all of you? So are you understanding what exactly the concept of elasticity is?
Yes, sir.
Okay.
Yes, sir.
Can I erase this? Come on, the rest of the students, what about them? Akshita, Ayush, Anirudh, Alicia, Avanti, Bhavna, Kevin, Gauri, Janani, what about you? Kavita, Kirti is getting it. Anshu, Arti, what about you?
Yes, I got it.
Okay, Shona, Sonika, Jana. Okay. Rohan and Ada, are you there? Rohan and Ada, are you there? Can I erase this, students? Can I erase this? Students, is the audio and video fine? Audio and video is fine with you all?
Yes, sir.
Yes, sir.
Okay, fine. Yes, Bhavika, I'll do that. I always do it. I always share it. Whatever your recordings are there all the time, I post it. But yes, the overall day end ke andar hota hai because I have certain lectures on a particular day. So I have 3 to 4 sessions going on at 6 to 8 hours of work. And then at the end of it, I give all together. No, my dear. Students, last lecture, did I post it? Yes or no? Tell me, rotational. Was it there on the YouTubes or not? Yes, Bhavika. They were uploaded on YouTube itself only. Bhavika, you're from which batch? You're from yellow batch? Okay. Is it fine, students? If the these recorded sessions have been uploaded on the YouTube, is it fine with you all, or you'll want it at your onto your into your house? Huh, students?
Sir, it's fine, sir.
Okay,
It's fine.
Okay, fine. Can I erase the students?
So 1 minute. So please, students, whenever somebody asks you elasticity, please always try to remember this and not this. Many students has a habit of remembering elasticity as what, a body undergoes deformation. Lekin deforming forces are removed, the body comes back to its original shape and size. That is applicable. But when we speak with respect to physics, students always say elastic bodies are those where when you apply deforming bodies, the body will try to resist. Please, the body will say no to that deforming force. Bhai, tu laga force, lekin I will not change myself. If a body has a high resistance to change in shape and size, such bodies are called to be more elastic. Now take a simple example, students, listen carefully. Suppose if I take two such cords, okay, two cords I'm taking it, one made up of steel, other one made up of rubber. Student, one made up of steel, other one made up of rubber. Both of them are of same length, same area of cross section. Hope you all are listening to me carefully, students. Okay, I'm giving you two cords. As of two wires, I'll give it to you. Both these particular are of same length, same area of cross section. One made up of steel, other one is made up of rubber. And student, what am I doing? I'm trying to suspend, listen carefully, I'm trying to suspend the maximum load which a rubber can bear. To both. Steel को भी मैंने लगाया, उसको भी लगा दिया. Lekin that means now when I subject it to external load, of course there is some load acting on the steel wire also. But out of the two students, which wire will be considered as more elastic? And give you the reason behind it. Two wires, one of steel, one of rubber, same length, same area of cross section, same loaded. Pathway has posted an answer. Absolutely correct, Pathway. Which one is considered to be more elastic? What will be your answer? Absolutely correct, Pathway. Yes, Saul. Saul is also correct. Anirudh is also correct. Absolutely correct. What about Kirti and others? Of course, steel is more elastic, students. The reason for steel being more elastic, that means there is a strong internal restoring force and steel will try to resist in its change in its shape and size. यानी कंपेयर करोगे ना रबर और स्टील में से स्टूडेंट्स, if such a question asks you in examinations and if they give you an option in that case steel or rubber में से, the student steel is more elastic, rubber is less, we consider. Do take care. So elasticity का मतलब ये नहीं है कि तुम स्ट्रेच करोगे और वापस छोड़ दोगे अपनी जगह पे आएगा. No. Elasticity is the property for a body to resist any change in its shape and or size. Such bodies are called to be elastic. Now let me go for a simple example onto this, which I told you. Can I erase this part, students? Can I erase this part?
Yes, sir.
Okay. Students, if in case if I happen to show it to you in this way, the graphical way of representation, students, this is x-axis, this is y-axis. Now suppose if I say, students, is the wire undergoing an elongation? You'll say yes, sir, the wire is undergoing an elongation. So there is elongation in the wire. लेकिन ये elongation किसकी वजह से? तुम बोलोगे सर फोर्स अप्लाई कर रहे हो ना, फोर्स की वजह से बॉडी elongate हो रहा है ना. Agreed? तो यहाँ पे डिपेंडेंट वेरिएबल कौन सा होगा, इंडिपेंडेंट कौन सा होगा? Can you tell me that? What should be the dependent variable? The wire is undergoing elongation when applied forces made to act on.
Force is independent.
Yes, and elongation is dependent. So dependent
Yes.
variable should come on which axis?
Y-axis.
Absolutely correct. And force will be on x-axis. This is how you can locate your graphs. Students, now listen carefully. Suppose if you try to perform an experiment in an experimental room, you go into your schools and you perform an experiment. They'll give you a thin steel wire, students. They'll give you a thin steel wire, they'll give it to you. And then you start loading this particular wire. Agreed? And then you, with the help of a Searle's method, the name of the experiment is actually Searle's method. You try to measure the length, the elongation. So as applied force goes on increasing, what happens? Elongation also will increase. As applied force elongation also will increase. जैसे applied force होगा, elongation force increase होगा. We have to understand elasticity, student. We have to understand elasticity. So I can't extend the force to a great extent. ये जो क्या है मालूम है, force applied से body elongate होता है, तो ये क्या हुआ? ये क्या हुआ? ये हुआ longitudinal stress. Longitudinal stress का definition क्या है? Restoring force per unit area. That means restoring force is the force acting normally per unit area of a given surface. Can I call it equal to applied force per unit area? Yes. लेकिन ये कौन सा stress हुआ? Longitudinal or tensile. Now I'll come back, students. Suppose I said it that you start unloading it now. Students, now I'm trying to unload it. Let us say I have loaded to 1, 2, 3, 4 and 5 kg. 5 kg तक 1, 2, 3, 4, 5 kg तक 6 kg तक मैंने लोड किया. अगर मैं अनलोड करूं, ध्यान से देखना, मैं अनलोड किया यानी आई एम रिमूविंग दिस वेट, देन अगेन आई एम रीचेकिंग विद माय एक्सटेंशन. वापस मैं ये वेट को निकाल रहा हूं, वापस मैं रीचेक कर रहा हूं बाय एक्सपेरिमेंटल व्हाट इज एग्जैक्टली द elongation is. As I go on unloading the wire, what happens? As I go on unloading the wire, as I go on unloading the wire, what happens? The wire comes back to its original shape and size. That means my graph will come back to origin. Students, my graph is going to come back to origin. That means you have made the wire to undergo extension within a particular limit, and that is called as elastic limit. Why? Because we are understanding elasticity. I don't want to understand any other property. Suppose अगर मैंने 1, 2, 3, 4 तक लिया, 5 और 6 में क्या हुआ? 5 और 6 में अगर मैंने 5 kg 6 kg लेना शुरू किया, what happens? वायर elongate हो रहा है, लेकिन उसका diameter change होना शुरू हो गया. Students, वायर elongate हो रहा है, लेकिन diameter change होना शुरू हो गया. What is happening in that case? What is happening? Oh sir, the wire is changing its characteristics. The wire is changing its characteristics. That means, will I get a straight line graph? No, your graph will be a bend. Your graph will be a bend in that case.
That means the graph is a bend. That means there is now going to be change in shape. If your graph goes in this manner, that can be permanent deformation. How do you prove there is a permanent deformation? यहाँ से unload करना शुरू करो ना. देखो इसके लिए ये लोड आया, इसके लिए ये लोड है. अगर तुम इसको अनलोड करना शुरू करोगे स्टूडेंट्स, तुम्हारा वायर will not come back to origin. If you start unloading, your wire might come back at this point. Your origin might shift. This shows the wire has undergone permanent deformation, and this is what we call plasticity. So students, from a graph also one can come to know about it. Are we speaking about elastic limit or have we crossed elastic limit? When you cross elastic limit, what's going to happen? The wire can undergo elongation. It can be permanent elongation, or the wire can break. The wire can break. Suppose if I show it in this manner and no more graph over here. हुआ क्या है? Wire तोड़ गया. Ductile. One more new property, ductility. So students, whenever you speak about elasticity, see to it that elasticity is always defined as a property by virtue of which a body resists any change in its shape or size. Such bodies are called to be elastic bodies we consider. Now, when I speak about elastic bodies we consider, we say about stress. What is stress? Restoring force acting normally per unit area. Can I call it as applied force per unit area? Why not? It's mg upon pi r square. What exactly restoring force do? We'll try to restore the body back to its original shape and size. Agar main unload karunga students, so am I getting my graph back? Yes. Getting the graph back to origin, what is that stress is called? Compressive stress. यानी स्टूडेंट्स स्ट्रेस के अंदर भी एक लॉन्जिट्यूडनल और एक कंप्रेसिव है. लॉन्जिट्यूडनल क्या करता है? लॉन्जिट्यूडनल क्या करता है? उस वायर को एक्सटेंड कराता है. डायमीटर चेंज नहीं हो रहा है. कंप्रेसिव स्ट्रेस क्या करो? अनलोड करो ना, अनलोड करो ना, वायर अपनी जगह पे आ जाता है. That's why there are two kinds of stress, students. It can be longitudinal or it can be compressive. The other word of longitudinal is also called as tensile stress. If I try to plot a graph of extension versus force applied or elongation versus force applied, then elongation becomes a dependent variable, force becomes independent. The graph will be straight line, and this straight line will always exist within elastic limit, up to the elastic limit. Then comes your proportionality limit we can consider. That's how we can consider. Yeah, ये part clear हुआ students?
Yes, sir.
Now, when you speak about the next part of it, the next kind of stress we consider is what? Volume stress. Stress we consider. Stress, I can say restoring force acting normally per unit area. That can be numerically equal to force applied perpendicularly per unit area. That is equal to mg upon pi r square. Agreed? That's your formula, students. Okay. The unit of this simply we can consider in terms of what? Newton meter square inverse. That's longitudinal stress, students. Now we go for volume stress. So volume stress speaks about what? You consider a football, students. Let us take a simple kind of a football. Okay, a spherical shape. Okay. Now suppose अगर मैं इसको inflate करता हूँ तो क्या होगा? उसका volume बढ़ेगा. Agreed? अगर मैं इसको deflate करूंगा तो क्या होगा? उसका volume कम होगा लेकिन shape change नहीं होगा. Shape वैसे ही है. यानी either तुम inflate करो या deflate करो, दोनों केस में क्या हो रहा है? There is change in volume, but the shape remains constant, but the volume changes in this case. Now what is happening? What is happening? Suppose अगर मैं decrease करता हूँ, let us say this is my initial pressure, and this is the final pressure. Agreed? What exactly volume stress we consider, students? If I say volume stress, students, stress is nothing but what? Restoring force per unit area, which can be numerically equal to applied force acting normally per unit area, I can consider. That's numerically. That's why they have same dimension we consider. So now volume stress is what? Volume stress we consider is force acting normally per unit area. We consider. That's volume stress we consider. If I say force acting normally per unit area, means can I say simply that is change in pressure. देखो ये final और ये initial. Final pressure is greater than initial pressure we consider. जब भी तुम बॉल को कंप्रेस करोगे स्टूडेंट्स, तो कहने से फाइनल प्रेशर इज ग्रेटर देन इनिशियल. सो कहने से वॉल्यूम स्ट्रेस का मतलब क्या है? फोर्स एक्टिंग नॉर्मली पर यूनिट एरिया, which is also equal to change in pressure. What exactly the unit in this case? So the unit can be written as Newton meter square inverse. Since I speak about pressure, can I use the variable? Can I use the unit as Pascal? Students, can I use the word Pascal in this case now? Is this clear? Students, is volume stress clear with all of you all?
So can you explain it once again?
Now see, what exactly volume stress, students? Volume stress is what exactly we consider is, listen carefully. Either I try to inflate a football or I deflate a football. Inflating the football, the football was spherical. Inflate करने के time क्या हुआ? उसका volume बढ़ा. That means there is some force exerted normally per unit area of the surface. Agreed. At the same time, the surface of the football was creating a restoring force. या अगर suppose मैं deflate भी करता हूँ, if I try to remove some air, agreed. So there is some force exerted per unit area on the walls. That means there is some pressure acting. What is that pressure we can consider? Change in pressure. What is change in pressure? Final minus the initial. Your final pressure in this case, suppose if I'm trying to compress, students, if I'm trying to compress it, my final pressure will be greater than initial. अगर मैं इसको deflate करता हूँ, my final is greater. अगर मैं inflate करता हूँ, are you getting it? In that case also my initial and final we consider. So in that case, we have volume stress is defined as what? Volume stress is simply considered as what? Force acting normally per unit area of a given surface. That is simply considered change in pressure because there is change in force acting per unit area. The unit of volume stress is Newton meter square inverse or simply considered Pascal. Is this clear, students?
Yes, sir.
Yes, sir.
Now, when I speak about shear stress, the answer is not shear stress. This word shear actually speaks about what, students? यहाँ पे क्या हो रहा है मालूम है? यहाँ पे shape change हो रहा है, volume constant. देखो ध्यान से देखो, फर्क देखो. यहाँ पे क्या हो रहा है? यहाँ पे shape constant हो रहा है. देखो ना, shape same है, circular ही है, volume change हो रहा है. यहाँ पे क्या हो रहा है? Students, over here, shape changes, volume remains constant. I repeat, please everybody listen carefully. Shear stress में मैंने क्या बोला? Shape is changing, but volume remaining constant. Let us understand the shear stress. What is stress? Force per unit area. Let us understand this part. Now to make this clear, students, let us understand this. Suppose if I consider I have a pack of cards, or I have a thick book. So think as if I'm having a thick book. So suppose in case if I happen to go for a thick book, okay. Now this is a thick book I'll consider in this case. Suppose if I say lower layer को मैंने fixed रखा, students, I'm keeping the lower layer fixed, okay, I'm not moving it. लेकिन मैंने क्या किया? Try to understand this. I'm applying a tangential force. Look over here. If I'm applying a tangential force, now see, how does the shape? How does the shape? If you see the shape,
Rhombus.
I happen to drop, yes. Means now see, if I happen to drop a perpendicular, students, from here. This is a perpendicular, students. Don't you think so? Each and every paper has undergone a displacement. है ना? और देखो जैसे जैसे पेपर का हाइट बढ़ रहा है स्टूडेंट, जैसे जैसे पेपर का हाइट बढ़ रहा है उस पेपर का लीनियर डिस्प्लेसमेंट बढ़ते जा रहा है. Agreed?
Yes, sir.
Now see, if I give you in this manner, what is the volume of this book? What is the volume of this book? So what do you say? Base area into height. What is it? Base area into height. And that's volume of the. Now suppose if I shift in this manner, what is the volume of this also? Base area remains the same, students. Base area remains the same, and perpendicular height which I drew it over here. This was the perpendicular height which I drew it. Students, in that case, what has happened? What has happened? Did I change the volume? No, but the shape changed. This is called a shear stress. यानी मैंने क्या किया मालूम है? अगर मैं इसको AB लेता हूँ स्टूडेंट्स, ये टॉप लेयर है, ये बॉटम लेयर है, ये मैंने बॉटम लेयर को मैंने फिक्स रखा स्टूडेंट्स, इसको मैं मूव नहीं कर रहा हूँ. The lower layer is fixed between two rigid points, the rigid ends. I'm trying to give a tangential force. Students, I'm giving a tangential force. Force tangential. Which on the upper layer, तो होगा क्या? Then what happens? The upper layer will undergo change in its position. Yani suppose if I look at this point A might reach to A dash, B might reach to B dash. Now see, is there any change in position? Yes, sir. Look what happened to the shape. If I would have gone for the diagram, students, if I go for the diagram was initially, students, the diagram was initially was a cuboid, it's a rectangular parallelepiped. स्टूडेंट्स ये A था, ये B था और ये बेस एरिया था. वॉल्यूम क्या था? स्टूडेंट्स वॉल्यूम क्या था? बेस एरिया इनटू हाइट. बट नाउ इसको अगर मैंने फोर्स दिया तो देखो नाउ माय शेप विल चेंज. एग्रीड? See my base area into height. My base area into height will remain the same in that case. But what happened to each and every layer? Each and every layer. So जैसे जैसे vertical height बढ़ता गया, जैसे जैसे vertical height बढ़ता गया, जैसे जैसे vertical height बढ़ता गया, कहाँ से? From the fixed layer. Look at that lateral displacement of the layer. So the lateral displacement also went on increasing. क्या ये clear हुआ students? Is this clear? So now can I say?
Yes, sir.
Now can I say what exactly shear stress is? Shear stress is simply we consider as what? Shear stress is defined as volume stress is what, students? Force acting normally per unit area, simply called as change in pressure. What is shear strain we consider is? Shear strain is force acting tangentially. This force acting tangentially per unit area of a given surface. What is the unit of this also? This is Newton meter square inverse or Pascal. What is the unit of here also? Newton meter square inverse. But in all the cases, is my formula force per unit area, force per unit area, force per unit area? Yes. Over here, it's applied force per unit area. Over here also can be applied force per unit area. There is change in pressure. But for shear stress, students, for shear stress, don't go for applied, go for tangential applied force. The force is applied tangentially per unit area. Let us say that this displacement A to A dash and B to B dash is your lateral displacement, and that is taking place at an angle theta. Students, this angle theta is called as which angle? Shear angle. When I showed you the book, students, and it was displaced, did you saw that angle formed over there when I dropped a perpendicular? Was that angle very large or very small? Angle formed, was it very large or very small? It was very small. Students.
Very small.
That angle we call a shear angle measured in radians. Hope the three types of stress are clear to you, students. So when you speak about stress, how is stress defined as? Stress is restoring force acting in area, students. And that is longitudinal stress, volume stress, shear stress. Longitudinal stress is force applied per unit area. Volume stress is simply change in pressure. Shear stress is tangential force per unit area. The unit of all three remains the same. Now,
So,
yes.
so how will find the tangential force here?
Pardon?
How will find the tangential force here?
Now, see, when you're speaking about the force applied, we try to suspend the body vertically in that case. We try to keep the body, see, when I try to go for it, we try to keep a force, the body is placed in such a manner that one end is kept rigid and the other, the force is applied, and we can go for a spring force also over here. You can go on applying force. The mechanical force is applied so that you can try to find out. Either you can keep it in vertical motion, doesn't matter. And then the force is
Okay.
applied over there also, doesn't matter. But that is your tangential force acting per unit area we consider. Okay. Now, students, due to stress, the body undergoes a strain. A stress is always accompanied by a strain. Students, a stress is always accompanied by a strain. Now, if somebody asks you what exactly strain is, then your answer for strain is what? Strain is simply, students, change in dimension. Strain is change in dimension upon original dimension. That is why, students, strain has no unit. It's dimensionless. It's m raised to 0, l raised to 0, p raised to 0. It has no unit. It's a pure ratio. If somebody asks you, does strain has any unit? No, it's a pure ratio. Why? Because it's a ratio of change in dimension upon original dimension. Since there are three kinds of stress, means there are three kinds of strains also. Suppose if I happen to go for longitudinal strain. What is longitudinal tensile stress? Force acting non-molecular area, applied force. If I happen to go for longitudinal strain, what exactly we consider, students? Longitudinal strain. Students, when the wire was loaded, was there any change in length? Yes. Longitudinal strain is, students, change in length upon original length. So-called elongation upon original length. So-called extension upon original length. Now see, look at the numerator. Is the numerator change in dimension? Yes. When you took the wire, students, when you took the wire was of length L. जैसे तुमने लोड किया तो वायर का लेंथ बढ़ा, तो ये न्यू लेंथ हुआ. न्यू लेंथ में से ओरिजिनल लेंथ निकाल दोगे तो वो क्या बचेगा? चेंज इन लेंथ होगा. With respect to what? Original length. What is that we call? Longitudinal strain. So longitudinal strain, students, simply is considered as what? Change in length upon original length, students. And it's a pure ratio we consider. Likewise, if I ask you, what exactly volume strain? Then what is the answer? Change in volume upon original volume. See, if I try to exert pressure, we consider, let us say this is the initial pressure, this is the initial volume, final pressure, so final volume. But students, due to increase in pressure, is volume decreasing? Yes. Pressure बढ़ रहा है, volume कम हो रहा है. Because pressure and volume has inverse variation we consider. So what is volume strain, students? Volume strain is change in volume upon original volume. Will it have any unit? No, it has no unit. It's a dimensionless quantity. So likewise, when I can say longitudinal strain is dimensionless, volume strain is also dimensionless. What about shear strain? It's also dimensionless. What is shear strain? What is the deformation taking place? What is the change over here taking place? Numerator क्या होगा? It's a change in the lateral displacement, sir. ध्यान से देखो, पहले ये AB यहाँ पे था, that is A was over here, and B, now this much is the lateral displacement. Can I say this is your lateral displacement? And it's fixed. Its distance from the fixed layer is h. So now when somebody asks you, students, what is shear strain? Listen carefully. Shear strain is defined as lateral displacement per, students, lateral displacement per unit perpendicular distance from fixed layer. Students, your shear strain है क्या? change in dimension upon origin. What is change? What is changing over here? So this x is changing. ध्यान से सुनना स्टूडेंट्स, जैसे जैसे हाइट बढ़ेगा वैसे x की वैल्यू बढ़ेगी. देखो ना, ये हाइट h1 है तो ये करस्पॉन्डिंग x1 है. अगर मैं हाइट और बढ़ाता हूं तो देखो ये x2 होगा फॉर हाइट h2. यानी what exactly this perpendicular distance from the fixed layer is h. What is lateral displacement is x. Which trigonometrical term, students, gives you a relation between x and h? Opposite upon adjacent. This is a hypotenuse. So what exactly that we consider is tan theta. So can I say shear strain is nothing but tan theta only? What is shear strain? Simply we consider tan theta. What is tan theta? Opposite upon adjacent. Is this theta very large or very small? Very small. So can I be nearly equal to theta? Why not? How do you define shear strain? Shear strain is defined as what? It's lateral displacement. Lateral displacement to its perpendicular distance from the fixed layer. To its perpendicular distance from the fixed layer. So x by h. Now, will it have any unit? No, it has no unit. So students, when there are three kinds of stress, there are three kinds of strains. Which are the three kinds of strains we consider? Longitudinal strain. Change in length upon original length, no unit. Volume strain. Change in volume upon original volume, no unit. Shear strain. Lateral displacement to its perpendicular distance from fixed layer x by h, which is equal to tan theta, which is nearly equal to theta. Why? Why tan theta is nearly equal to theta? Because of this angle is very, very small. What is the name of this angle called? Shear angle. So there are three kinds of stress, three kinds of strain. Stress has Newton per meter square as a unit. Strain has no unit. Is this clear to all of you? Students, is this clear? Stress and strain? Can I erase, students? Can I erase it? Fine. Okay, students, when I speak about, I told you about stress, I told you about strain. There are three kinds of stress: longitudinal, also called as tensile, that is force acting normally per unit area, that is mg upon pi r square. Then your next part I'll consider will be volume stress, will be change in pressure or change in force acting normally per unit area. Then we consider shear stress force acting tangentially per unit area. The answer for all of them is Newton meters per inverse. Due to stress, the body undergoes corresponding strain. So you have longitudinal or tensile strain, which is equal to change in length upon original length. It has no unit, so its dimension is m raised to 0, l raised to 0, t raised to 0, no unit. Then you have volume strain, we consider, that is change in volume upon original volume. Then you have your shear strain, and that is equal to tan theta, which is nearly equal to theta, and that is your lateral displacement to its perpendicular distance from the fixed layer, and this angle is theta. This is called as shear angle. This I made it very clear, students. So tan theta will be nearly equal to theta, which is equal to x by h. Now, it was Hooke's who actually gave a law, and that's called as your Hooke's law. Since Hooke's law actually gave a relation between stress and strain, and he said it that stress is directly proportional to strain. Since stress is directly proportional to strain, that was put forward by Hooke. It is actually what he considers strain ka matlab kya? Change in dimension of original dimension. We consider stress is what? The force acting normally per unit area, we consider that is restoring force. So as such, if I say restoring force per unit area, of course, is proportional to what? Change in dimension upon original dimension. Students, यहाँ पे stress को applied force नहीं लेता है, restoring force. Restoring force per unit. अभी please students ध्यान से सुनना. अगर तुमने कोई बॉडी का अप्लाइड फोर्स बढ़ाया, स्टूडेंट ध्यान से सुनना, अगर ये वायर है, अगर तुमने इसका अप्लाइड फोर्स बढ़ा दिया तो क्या से बॉडी elongate होना शुरू करेगा, तो डिस्प्लेसमेंट होना शुरू करेगा, द बॉडी विल अंडरगो elongation और एक्सटेंशन. लेकिन उसी टाइम पे कौन सा फोर्स अंदर की तरफ बढ़ रहा है? रिस्टोरिंग में तो बढ़ रहा है ना. स्टूडेंट्स ध्यान से सुनना, डिपेंडेंट वेरिएबल और इंडिपेंडेंट कैसे आते हैं यहाँ पे? बहुत सारे स्टूडेंट्स ये सोचेंगे सर हाउ कैन यू से स्ट्रेस प्रोपोर्शनल टू स्ट्रेन? So strain is change in dimension and that depends on the stress. जितना stress उतना strain. लेकिन students यहाँ पे stress को क्या लेते हैं? Applied force नहीं. Restoring force acting per unit area. Now see, this is your stress. Is proportional to change in dimension upon this was your original dimension. What is the reason for this change? Because of applied force per unit area. This is very, 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 very important point. Even the textbook also doesn't speak about this. Many students has a query and they raise questions. Sir, how is it possible that when Hooke's tried to put forward the law, he said it stress is proportional to strain. But as such, if I look at the graphical way of representation, everybody listen carefully. On y-axis, you should get dependent variables. On x-axis, you should get independent. So, अगर मैं नाम के हिसाब से देखो, तो strain should depend on stress. How could stress depends on strain? तो अगर मुझे ग्राफ बनाना है स्टूडेंट्स, अगर मुझे ग्राफ बनाना है तो मेरा ग्राफ के अंदर y एक्सिस के ऊपर यहाँ पे क्या आना चाहिए? डिपेंडेंट वेरिएबल स्ट्रेन यहाँ पे आना चाहिए. But when you see your graph students, यहाँ पे on y axis they're given as stress, and over here they've given strain, and it's because of this relation. Students, once again, as applied force goes on increasing, elongation, extension will increase, but at the same time, restoring force also will increase. Now let us go for the original dimensions. This force is acting per unit area. This is per unit area. This is per unit length. What is this becoming? Stress. What does this become? Strain. What kind of variation is this? Direct. So now when somebody speaks about Hooke's law, students, we need to go for stress on y-axis and we consider
strain on x-axis. No unit, and this has Newton per meter square on y-axis. Now this particular graph will reach to a particular point. Are you getting it? So the consider is it reaches to a particular point called as the elastic point. Since that means this is an elastic point. So within elastic limit, this is called as your point E is called as the elastic limit. Within elastic limit, students. What exactly Hooke's law states? Within elastic limit, students, stress is directly proportional to strain. And this is what your Hooke's law is. Hooke's law states that, students, within elastic limit, stress is proportional to strain. If stress is proportional to strain, that means I need to get some constant. The ratio all the time should remain a constant. What is that constant I consider as? Elastic constant. Of course, the ratio remains constant. What is that constant called as? Elastic constant. Now, when you classify stress are how many types? So stress are 3 types. First, second, third. How many types of strains are there? 3 types, 1, 2, and 3. If there are 3 kinds of stress, if there are 3 kinds of strains, what about the corresponding elastic constant also? Should be 3. Which are they? Young's modulus, bulk modulus, and modulus of rigidity. Which are the 3 elastic constant? The first elastic constant is Young's modulus. Second is bulk modulus. And third is modulus of rigidity. So the 3 kinds of elastic constants are given certain names. Young's, it was put forward with respect to physicist Thomas Young. Bulk modulus, we consider, and modulus of rigidity. ये 3 elastic constant है. क्यों 3 elastic constant? Because there are 3 stress and 3 strains. Each stress, the first one, the answer is, students, the first one corresponds to the first strain and the corresponding constant is Young's. For the second one, we have a second strain and the corresponding considers a bulk modulus, the ratio of it. And for the third one, students, we have the corresponding constant is modulus of rigidity. Young's modulus denoted by variable y, bulk modulus k or b, and modulus of rigidity is pronounced as eta, ETA. This is the symbol for modulus of rigidity, students, pronounced by Greek alphabet eta. Is this much clear to all of you, students? As strain increases, stress also increase. Stress and strain have direct variation, but will go only up to the elastic limit. Beyond this, if I happen to go for it, the wire will change its characteristics. So I have to speak about constants. Students, is this part clear to all of you? Students, are you getting it? Yes or no?
Yes, sir.
Okay. Can I erase it now?
Yes, sir.
Okay. That means, students, if I happen to go for slope of this graph in the first case, तो ये क्या होगा? F by A. ये क्या होगा? E by L. What is the slope of this graph? Y. Friends, what is Y? What is Y we consider?
It's y2 minus y1 upon x2 minus x1 minus when I say f by a ratio of y to ratio of x. So what's the formula for Young's modulus? What is Young's modulus? It's a ratio of what? It's a ratio of longitudinal stress to longitudinal strain. That means what? Force acting normally per unit area divided by this into L by E. Did you get the formula for Young's modulus? It's longitudinal stress to longitudinal strain. Ratio of the two will give me the slope. Students, सारे केस में ratio ही आएगा क्योंकि straight line graph आ रहा है. And all of you have done basic maths. For a straight line graph, students, which is passing through origin, we consider y is equal to mx plus c. Y is equal to mx. C is 0. यहाँ पे अगर मैं रेशियो लेता हूँ स्टूडेंट्स, मेरा रेशियो कांस्टेंट आ रहा है तो ये हुआ मेरा फॉर्मूला. अगर यही Young's modulus को if I want to write in a better way, what do you write down, please? Y is equal to what, students? It's f by into L by E. Force क्या होगा? mg. What is A stands for? Area of cross section of the wire. Students, that is pi r square. What is L? Original length. What is E? Elongation or extension. This answer will be in Newton meter square in the students. So when problems are asked, you can use this formula. Please, again I repeat, many students will try to remember Young's modulus as longitudinal stress upon longitudinal strain and they'll say applied force per unit area, but actually it is also restoring force per unit area into L by E. Is this clear? This is your first formula for Young's modulus. Bulk modulus क्या है? Sir, bulk modulus, अभी देखो इसको मैं निकाल देता हूँ मैं. What is bulk modulus? So bulk modulus is a ratio of what? It's a ratio of two. It's a ratio of stress and strain. Which one? It's volume stress to volume strain. What is volume stress, students? Because there is increase in pressure, and due to increase in pressure, what is happening, students? Is the volume increasing or decreasing? What did you saw about the football? When the pressure was increased, what happened? The volume decreased. Increase in pressure decreases the volume. That is why, students, bulk modulus is represented with negative sign. Please, very important. Delta V upon V, change in volume upon original volume. If somebody asks you, in bulk modulus, why do you use negative sign in the formula? Why do we use negative sign in the formula? What will be your answer? Your answer is increase in pressure decreases the volume. Do take care when you are actually putting forward the mathematical relation. But generally, students, when you do numericals based on to this, we simply go in terms of its magnitude. We do not consider the negative part. Negative are simply increase in pressure decreases the volume. That's all. So I can simply say K is equal to change in pressure upon change in volume upon original volume. अगर मैं इसको rearrange करके लिखूं तो कैसा होगा? देखो, minus delta P V upon delta V. What is the unit of bulk modulus? I can simply write it in terms of Pascal, capital P and small. Now you have modulus of rigidity. What is modulus of rigidity? It's again an elastic constant. It's a slope. It's a slope of kiska. Slope of what? Stress and strain. Which stress? Shear stress. Shear strain. Shear stress on one axis. Shear strain on x axis. अगर इनका मैं रेशियो लूं तो मुझे मॉडुलस ऑफ रिजिडिटी मिलेगा. What exactly modulus of rigidity, students? It's shear stress upon shear strain. And what is the formula, students? What's the formula to get it? Shear stress is what? Force tangentially per unit area. Divided by what? What is shear strain? Simply tan theta. Is this clear? So what exactly eta can be written as? Your eta, students, your eta का formula क्या होगा? Force tangential per unit area into tan theta. I can run this manner. Or is this theta very large or very small? Very small. I can also put in theta. Or can I run this as what? F by A. What is tan theta? Students, what is tan theta? X by H. X by H. So can I put this as X over here? By H. Is this formula for modulus of rigidity? And what is the unit? What is the unit? Newton per meter square. Are the three formulas of all the three constant clear, students? Formula for Young's modulus, formula for bulk modulus, formula for modulus of rigidity. Young's modulus is F by A into L by E, which can be written in this manner. MgL upon pi square E. What is bulk modulus? Volume stress upon volume strain. Change in pressure into V upon change in volume. Why do we use negative sign? Increase in pressure, decrease the volume, decrease in pressure will increase the volume. Inverse variation. Modulus of rigidity, eta, it's shear stress to shear strain. F upon E tan theta. Tan theta is in denominator. So either I can write in this manner, or instead of tan theta, simply I can write on theta measured in radians, or I can write on F by A x h fh upon px. This is lateral displacement upon perpendicular distance. वो ऊपर चला गया. What is the unit of this also? Newton per meter square. Newton per meter square. Newton per meter square. This can also be put forward in terms of mass. Students, are the three formulas of all the constants. So there are three kinds of stress, there are three kinds of strains, therefore there are three kinds of elastic constants also. Young's modulus, bulk modulus, modulus of rigidity. Students, is it clear to all of you all?
Yes, sir.
Can I erase it?
So 1 minute.
This means can I erase now?
Yes, sir.
Yes, sir. Okay. Okay, so the next one we go for Poisson's ratio. So Poisson's ratio simply sigma we consider. What is this? Students, this actually speaks about, see, when I told you about the previous example, when I was elongating a wire, since the wire was undergoing an elongation, there was longitudinal strain taking place. But when the wire was elongating, students, was there any change in diameter? Did I speak about change in diameter?
No, sir.
Because when I said about strain, जब भी मैंने तो वहां पे सिर्फ लेंथ के हिसाब से चेंजेस हो रहा था, diameter wasn't changing. And that is what we say, that the body is not undergoing any change in diameter we consider. So that was within elastic limit. Now, what is Poisson's ratio actually speaking about? That suppose if I take a wire, students, and if I try to load this wire, what happens? What happens in this case? If I'm starting loading this particular wire, what happens? जैसे जैसे तुम्हारा load बढ़ता गया, what's going to happen? जैसे जैसे load बढ़ता गया, what's going to happen? The wire will undergo elongation. That means if the wire undergoes elongation, students, will there be any change in diameter? It can be possible, but when? When is this possible, students? When is this possible? This is possible only beyond elastic. देखो ना स्टूडेंट्स, डायमीटर देखो, पहला वाला देखो स्टूडेंट्स, ये वाला देखो, ये कैपिटल डी है, ओके, ओरिजिनल डायमीटर. ये जो है न्यू डायमीटर, डॉटेड वाला, है ना. व्हाट इज चेंज इन डायमीटर स्टूडेंट्स? फाइनल माइनस द इनिशियल. क्या चेंज का मतलब क्या हुआ स्टूडेंट्स? चेंज क्या होता है? हमेशा फाइनल में से इनिशियल निकालोगे ना, भले ही आंसर नेगेटिव आ रहा है. हेलो, ये देखो ना, ये डायमीटर बड़ा है, ये वाला छोटा है. चेंज इन डायमीटर का क्या मतलब हुआ? फाइनल माइनस द इनिशियल. So there is change in diameter taking place. और ये किसकी वजह से हुआ है? Because the wire was undergoing elongation. Did you loaded the wire to a certain more extent? Yes, we had loaded the wire due to some more force. That means, students, you have just crossed the straight line part of the graph. You have just crossed the straight line part of the graph, students. If I speak about the graphical representation, students, on x-axis and on y-axis, students, if I happen to speak about the graphical representation of stress, students, the graph will be straight line till a particular point P. It can maintain that straight nature. It can maintain that straight nature to still a point E. But beyond point E, the graph will be a bend. Students, listen carefully. This is what we consider is your straight line graph till P, then till E. P और E के बीच में, students, the gap is very small. Yani this is actually your proportional limit. This is called as elastic limit. Students, मुझे ये बताओ how to understand this. Students, how to understand this? चलो P और E को कैसे समझते हैं? Everybody be with me for a second, please. Students, मुझे बताओ, suppose अगर ये circular track है ना students, totally going in a different concept ना students. ये एक circular track है और ये center है, और तुम्हारी एक कार, ध्यान से सुनना स्टूडेंट्स, ये सर्कुलर ट्रैक में मूव हो रही है. Agreed? Suppose if I say that the track has shown a speed of 100 kilometers per hour. Okay. Now there are three drivers who are trying to drive the car on this road. One drives with 80 kilometers per hour. Another drives with 100 kilometers per hour. Third drives with 120 kilometers per hour. And the limit of this track is given to us 100. Agreed? Students, मुझे ये बताओ, अगर मैंने पूछा क्वेश्चन, what is the maximum speed over here out of these three? Agreed? Which is the safe speed out of this three? And which is a speed for the car to topple? क्या बोलोगे? सर्कुलर ट्रैक है, उसका मैंने स्पीड लिमिट लिखा हुआ है 100 किलोमीटर पर आवर. तीन कार्स उसमें से जा रही है, 3 lanes है. Agreed? इसका maximum limit is 100 we consider. एक बंदा 80 से चला रहा है, दूसरा 100 से चला रहा है, एक 120 से चला रहा है. My question to you all is, which will be the maximum speed of the three? Which is a safe speed and which is a speed for it to topple so that the car can overturn?
Maximum is 100, safe is 80, and topple is 120.
Exactly same thing over here. This is we consider as safe. This we consider as maximum. Beyond that, what's going to happen? Toppling effect, wire will change its shape. Is this clear, students?
Yes, sir.
And point P और ये क्या है? Students, point P and here what are very close. They are very close to each other, we consider. Is that clear? Because normally if I want, suppose if it's 100, people will go at 90 and 95, which is closer to it. Am I getting it? So that's how we consider to avoid calamities. Now, students, what exactly? That means what is happening over here? I've loaded. So देखो loading से हुआ क्या? Sir, वायर ने अपना diameter change कर दिया है. Length भी तो change हो रहा है ना? देखो ना. Length पहले ये था L, अभी length L dash हो गया. What exactly change in length? Final length minus original. Sir, change in length तो positive में आ रहा है, लेकिन change in diameter तो negative में आ रहा है. ये कभी होगा? Due to loading. Due to loading, please students, what is happening? The wire is undergoing longitudinal. Students, due to loading, the wire is undergoing longitudinal strain. But at the same time, does the wire has lateral strain taking place? Yes, sir. There is decrease in diameter. Yani, your longitudinal strain and lateral strain are mutually perpendicular to each other. Absolutely correct. जैसे जैसे मैं लोड करते गया, वायर elongate होते गया, लेकिन साथ साथ में उसका डायमीटर कम होते गया. अगर सपोज मैं अनलोड करूं, अगर मैं सपोज अनलोड करूंगा, तो now the wire will undergo longitudinal compression. Longitudinal compression. Will there be lateral compression? Yes, there can be lateral compression. Till where? Till E तक. Till E के, ये P और E जो भी खेल है वो P और E के बीच में या E से जस्ट बाहर. अगर तुमने ज्यादा लोड कर दिया तो वायर अपना शेप चेंज कर देगा. Students, that is why this doesn't comes under elastic constant. Everybody listen carefully, students. What is elastic constant? What are the three elastic constants? You had Young's modulus as elastic constant. You had bulk modulus here as elastic constant. You had modulus of rigidity elastic constant. Why they are called as elastic constant? Because it's a ratio of stress to strain, and it comes within the proportional limit. इसके beyond तुम थोड़ा सा भी चले गए तो क्या हो जाएगा? Now you're not within the elastic limit. That means the wire will undergo deformation. Poisson's ratio actually speaks about this concept. That means students, your lateral strain, that's as soon as students, your lateral strain is directly proportional to longitudinal strain. Agreed? Change in diameters because of change in length. So lateral strain is proportional to longitudinal strain. What is lateral strain? What is lateral strain? What is strain? Students, what is strain? Change in dimension upon original dimension. Laterally, यहाँ पे क्या change हो रहा है? So there is change in diameter. Change in diameter upon original diameter. If I put an equal to sign, remove the symbol of proportionality, I'm going to get a constant. What is that constant I'll call? Sigma. How do I pronounce this as? Sigma. What is this called? Poisson's ratio. What is longitudinal strain? Change in length upon original. So now, students, when somebody asks you, defines Poisson's ratio, so how do you define? Students, how do you define Poisson's ratio? So Poisson's ratio, students, is defined as the ratio of lateral strain to longitudinal strain. Students, it is a ratio of two strains. That is why it is m raised to 0, l raised to 0, t raised to 0. It has no unit. Students, it is a ratio of two strains. Is it a ratio of stress to strain like these? No, not at all. That's why it's not an elastic constant. Sigma is not an elastic constant. Now, if I want to go for the formula, what is lateral strain? Lateral strain is what? It's a change in diameter upon original diameter. What is longitudinal strain? It's a change in length upon original length. But as length increases, students, as length increases, does the diameter increase or decreases? Decreases. We put negative sign. That's why in this formula also you'll get the value of sigma in negative. Negative sign students ये दिखाता है अगर length बढ़ेगा तो diameter कम. It is said the value of sigma, students, the value of sigma lies between -1 and 0.5. Less than -1 or equal to 0.5 students. Generally for metals, if I have to consider, the value of sigma is equal to how much? 0.3. Always positive. Practically, हम positive में ही लेते हैं. Practical examinations में या practicals perform करेंगे तो sigma is always positive. This is theoretical value I'm putting. Is this clear, students? Concept of Poisson's ratio? So now when somebody asks you to define it in your examinations, defines Poisson's ratio, तो क्या करोगे? Poisson's ratio is defined as the ratio of lateral strain to longitudinal strain. That's all. What is the formula? Minus delta d by d into L upon delta L. That's all. Now, if I happen to plot a graph of stress versus strain for a wire to be loaded, what exactly points I'm coming across? The first point, students, P. What does point P stands for? Proportional limit. What does point P stands for? Elastic limit. Is the graph a straight line? Yes, the graph is simply a straight line. यानी अगर मैं यहाँ पे unload करूँगा ना students, if I start unloading, my graph will come back to origin. But now suppose if I happen to go further ahead, what happens? As stress increases, what happens? Strain also will increase. Now see my graph. My graph is going parallel. If I happen to take a point over here, students, what is this point I'll consider? This point I'll consider to be as M. What does this point M stands for? Permanent set. यानी अगर मैं यहाँ से वायर को डिफॉर्म करूँ, यानी यहाँ से मैं अनलोड करना शुरू करूँ, तो देखो मेरा ओरिजिन देखो कहाँ पे शिफ्ट हो गया. If I try to draw a straight line from M onto the x-axis, see my origin has shifted. This shows that this is point that is M, O, O dash, M, O, O dash represents permanent set. That means the wire is trying to change its characteristics. Now suppose if I happen to go for a point P over here, okay? So Y, not point D, point Y. What exactly point Y stands for? Yield point. Why is it so? Why is it so? Now see over here. Am I trying to change the stress? See the stress. Stress is constant. But does the wire undergoing an elongation? Yes. And what exactly? The wire has yielded a new characteristics. What is the characteristics? It is going for plasticity. Graph is parallel, students. यानी देखो स्ट्रेस नहीं बढ़ रहा है स्टूडेंट्स, स्ट्रेस नहीं बढ़ रहा है, लेकिन वायर फिर भी elongate होते जा रहा है. तो point Y stands for yield point. The wire has yielded a new characteristics. अगर सपोज तुमने और लोड करना शुरू कर दिया तो क्या होगा? सिर्फ वायर का वापस स्ट्रेस बढ़ेगा, स्ट्रेन भी बढ़ेगा. वायर का स्ट्रेस बढ़ेगा, स्ट्रेन भी बढ़ेगा. Agreed? Now suppose if I happen to go for a point, students, if I happen to go for a point on the y-axis, where students look over here, the wire has undergone maximum stress. This is called as breaking stress. Formula rho Lg. स्टूडेंट्स ये कौन सा स्ट्रेस है मालूम है? देखो ध्यान से सुनना. मैं यहाँ पे आने के बाद में वायर को वापस लोड कर रहा हूँ. लोडिंग शुरू है. आई एम गोइंग ऑन लोडिंग. बट सी द वायर इज अंडरगोइंग एन एक्सटेंशन. यस, वायर इज अंडरगोइंग. लेकिन मैं यहाँ तक लोड किया. नाउ सपोज स्टूडेंट्स, इफ आई स्टार्ट लोडिंग मोर देन दिस, वायर इज गोइंग टू ब्रेक. दैट इज व्हाई आई कॉल दिस एज माय मैक्सिमम स्ट्रेस, कॉल्ड एज ब्रेकिंग स्ट्रेस. नाउ आई एम नॉट लोडिंग द वायर. आई एम नॉट लोडिंग द वायर फर्दर, अदरवाइज वायर विल ब्रेक. I just want to know how does the wire behaves due to load. तो मैं क्या करता हूँ, यहाँ से मैंने वायर को अनलोड करना शुरू कर दिया. तो अभी मेरा ग्राफ के नीचे आएगा. ग्राफ अगर मैं लोड को कम करते रहूंगा तो क्या वायर अपनी जगह पे आएगा? नहीं आएगा, क्योंकि वो तो परमानेंट इलॉन्गेशन में चला गया है. स्टूडेंट्स, इसके बाद में भी तुम्हारा वायर क्या होगा? The wire will not undergo any kind of change. We consider the wire will simply undergo a permanent set, and finally at a particular point, this is called as a breaking stress, and this we consider as fracture point. So what exactly point S stands for? Point S, if I have to consider, will be standing for what? Breaking stress, and point F stands for fracture point, where the wire will form a weak constriction, very thin, and the wire will certainly break at this point. So have you understood behavior of a wire, students? This is a concept of behavior of a wire due to applied force. Students, वापस जैसे जैसे मैं applied force लगाते रहूंगा, my stress increases, strain also increases. It will go on to proportional limit, then comes elastic limit. Hooke's law are obeyed under this. This is a slope where you have y, k, eta. This is proportionality limit. This is elastic limit. When I cross elastic limit, the graph will be slightly curved. What does M stands for? Permanent set. Has the wire undergone permanent deformation? Yes, this is permanent deformation. If I try to increase the stress further, is the wire yielding a new characteristics? Yes. That's why Y is called as an yield point, and the characteristics is plasticity. Now, when I start loading the wire still further, what happens? The wire has reached to a breaking stress. What is a breaking stress? What exactly breaking stress, students? Breaking stress, students, is that maximum force acting per unit area. What is maximum force? M into G per unit area. What is mass? Density into volume per unit area. E will get cancelled. What's your answer? Rho Lg. That's why I wrote Rho Lg, students. Once again, breaking stress is what? Force per unit area. Force क्या है? mg per unit area. M क्या है? Mass. Mass क्या होगा? Density into volume of the wire. What is volume of the wire? Base area into height. Does the base area part get cancelled? Yes. So what exactly I'm getting it? Rho Lg. What is this called? Breaking stress. अगर मैंने इसके beyond ले लिया तो वायर टूट जाता, लेकिन फिर मैंने क्या किया? वायर को अनलोड करना शुरू कर दिया, फिर भी वायर elongate होता गया. At a particular point, what happens? The wire reaches to point F, and what does that point F is called? Fracture point. What does point S stands for? Breaking stress. Hope these all points are clear to the students. Is this clear to all of you all? Students getting it? Okay, can I erase it now? Suppose if they ask you, what is the maximum length which a wire can bear itself due to its own weight? Students, have you seen the Bandra ceiling? Bandra ceiling, अगर तुमने देखा होगा, it's a complete long stretch in water. And have you seen the bridge is suspended by those long rods? So of course there is a stress acting onto it, लेकिन that stress is distributed among several rods. अगर मैं कोई एक rod की बात करूँगा, it's a huge long rod, and the breaking stress for that rod is rho Lg. Students, this is what the formula means. L is the length of the rod, rho is the density of the material which is made, and G is gravitational acceleration. Friends, can I erase this? Friends, can I erase? Okay. Thank you, Tanishka, for texting. Okay. The last concept now. This is the last concept of the chapter, students. Work done. This is the formula for work done in elongating a wire. Okay, students. Formula for work done in elongating wire due to applied force. The formula we are going to derive is half into stretching force into elongation. This answer is in Joule. Okay, this is the last part of the derivation, students. And that will be the end of the chapter. This is work done. This work done gets stored in elongated wire in the form of elastic potential energy. Elastic potential energy. So at times someone asks you, what is elastic potential energy in extension of the wire? Half into stretching force into elongation. One more formula you'll be speaking about, work done per unit volume. Which is also called as strain energy per unit volume, which is also called as energy density. And students, over here the formula is half into stress into strain. And the unit is joule meter cube. We are trying to derive these two formulas, and they are very easy, students. Those students who are good in integration will be able to get it. Students, now please consider over here. बहुत ही easy वाला. Please pay attention, students. Think this is a wire. This wire I'm trying to let it undergo elongation. Please pay attention now. ये wire है, students. ये इसका original length है. मुझे ये wire को students elongate करना है. मुझे ये wire को elongate करना है. ध्यान से सुनना. Within elastic limiting. I'm not crossing the elastic limit. इससे देखो diameter change नहीं हो रहा है. I want to elongate the wire that is within elastic limit itself only, and I want to elongate the wire to its maximum elongation equal to E. Let the maximum elongation be equal to E. And this is due to the applied force. This is the applied force. The applied force over here is mg. That's the load. Friends, is the diagram clear to all of you? This is the original length. I want the wire to undergo an elongation. So what exactly? So this becomes L dash. So this becomes elongation. So can I say what is delta L, students? What is delta L? L dash minus L. Can I say that is equal to E? Students, is this clear? Hi, Anna. If you want to understand, students, please do respond. Otherwise, of no use pushing yourself into the lectures.
Yes.
Okay. Now, please pay attention. Answers, na? What are we trying to do? We are trying to find out work done in order to extend the wire. Students, हम क्या करते हैं मालूम है? हम ये wire को elongate करते हैं, students, and let us say that I'm trying to elongate the wire only to a particular distance x. Students, अगर मुझे wire को पूरा elongate करना होता, तो what is my formula for Young's modulus? तो मुझे सर it's F by A into L upon E. यानी ये F होगा, ये maximum force होगा ना? So that the elongation is maximum. तो अगर मैं F को subject बनाऊं तो students क्या होगा मेरा formula? YAE by L. ये किसके लिए है? ये किसके लिए है? सर ये है maximum force for maximum elongation. लेकिन हमने कहाँ तक elongate किया students? हमने elongate कर दिया यहाँ तक ही, ना कि पूरा. अगर मेरा elongation small x है students, तो मेरा applied force क्या होगा? क्या मेरा applied force capital F होगा? It will be small f. Students,
Yes,
will
sir.
it small f hoga? So now can you tell me what is the Young's modulus in this case? So the formula for Young's modulus over here will be, यहाँ पे small f आएगा. So area of cross section तो change नहीं हो रहा है. So original length तो same ही है. अभी आपका extension x हो जाएगा. X is equal to 0 to x आया. Can you give me the formula for f? Oh, sir, f is equal to what? Y a x by L, and this is for elongation x. But now what am I trying to do? I'm trying to elongate the wire from here. The answer is no. I'm trying to elongate the wire from here to a very small displacement dx. Students, I'm elongating the wire further. That means, am I doing some work? Yes, my applied force is downward. Am I doing some work? Yes, the work is done due to which force? Due to applied force and displacement. This work is done against which force? Internal restoring force. Students, ये जो हम काम कर रहे हैं elongate करने का किसके against कर रहे हैं? Restoring force को कर रहे हैं. That means the work done by me. Students, ध्यान से सुनना. The work done by me due to applied load gets stored in the wire. Gets stored in the wire in the form of which energy? Elastic potential energy. Students, elastic potential energy. तो ये जो work done है, that is elastic potential energy. So can I say work done is equal to force into displacement, students? Can I substitute y as what? Y a x by L into dx. This is small amount of work done. क्या ये clear हुआ, students?
Yes, sir.
Clear हुआ? If I want to find out total work done, कहाँ से कहाँ करना, students? Total work done. So we have to do the total work done from x is equal to 0 to x is equal to lower limit, upper limit आया तो क्या करोगे? Sir, infinite वाले element को integrate करो. Integration, take integration on both the sides. Integration lower limit यहाँ पे 0 होगा, यहाँ पे capital W होगा. यहाँ पे integration में lower limit क्या होगा? सर शुरू कर रहे हो आप x is equal to 0. कहाँ तक आपको elongate करना है? X is equal to e. What is integration of dw, students? What is integration of dw? W upper limit minus lower limit, give me w only, is equal to what is over here? Sir, Young's modulus is a constant. Area of cross section of the wire is a constant. Original length of the wire is constant. Integration of x into dx. X is equal to 0 to x is equal to e. Therefore, work done is equal to what? Y a L. What is integration of x into dx? X square by
X square
2.
by
What's the formula? Integration of x raised to n into dx. X raised to n plus 1 upon n plus 1. Lower limit क्या होगा? X is equal to 0 to x is equal to e. This is definite integral, so constant of integration नहीं आएगा. What exactly work done will be equal to y a by L. 2 नीचे आ गया. X की जगह क्या ना put? Capital E square minus 0 square. What's my formula? Work done is equal to what? देखो, half y a by L into e into e. So what is y a e by L? Can I say work done is equal to half into stretching force into elongation? I get to my answer. This is the formula. Clear, students?
yes, sir.
अगर मुझे चाहिए, what is the formula for work done per unit volume? Students, work done per unit volume, or so called the strain energy density. Simply work done per unit volume, find out W by V. यानी क्या करना है तुम्हें? Half F into E लेना है. वॉल्यूम किसका? तुम्हारा, मेरा या वायर का वॉल्यूम? सर वायर का वॉल्यूम ना, तो बेस एरिया इनटू हाइट ले लो ना. Students, what is the volume of the wire? What is volume of wire? What is volume of wire? Base area into height. It's a cylinder. Students must see. Half into. Students, what is force per unit area?
Stress.
Yes. What is E by L? Change in length upon original. What is that? Strain. Did I get my answer? Can I write on the same answer in some other way? Yes. Since we know that y is equal to what? Since we know that y is equal to stress upon strain. Can I substitute stress over here? So can I write on this as half into y into strain square? Students, देखो ना, stress को substitute करो. Y into strain. So half into y into strain. Can I substitute strain as stress upon y? So what will be the formula? So students, वर्क डन पर यूनिट वॉल्यूम, स्ट्रेन एनर्जी पर यूनिट वॉल्यूम, एनर्जी डेंसिटी, सब कुछ एक ही है। जूल पर मीटर क्यूब, कितने फॉर्मूलाज है? 3। पहला वाला क्या है? हाफ इंटू स्ट्रेस इंटू स्ट्रेन, दूसरा हाफ इंटू y इंटू स्ट्रेन स्क्वायर, तीसरा हाफ इंटू स्ट्रेस स्क्वायर अपॉन y. And what's the formula for work done in elongating the wire? Half into stretching force into elongation. Is this clear, students?
Yes, sir.
Yes.
That's the end of your chapter, elasticity, students. Okay, students, so please now, whenever you get time, try to go through it, try to go through the chapter also, put down the mathematical relations, and the problems are very easy, students. If you understand properly, if you read it very correctly with proper units, conversion to take care of it, you'll be able to crack the questions more easily. Okay, students? Shall we wind up?